Welcome to Edisla's deep dive into the Sun, our solar system's star. From our vantage point on Earth, the Sun appears as a constant presence in the sky, a source of light and warmth that we often take for granted. But the Sun is far more than a simple celestial lamp. Prepare to journey with us beyond the familiar glow of the Sun and delve into its extraordinary secrets. When we imagine the Sun, we might picture a giant burning ball, something akin to a massive campfire in the sky. But the Sun isn't burning in the way we typically think of it. Instead, the Sun is a gigantic sphere of plasma, a state of matter so hot that atoms are stripped of their electrons, forming a sea of charged particles. This plasma, primarily composed of hydrogen and helium, is constantly churning and roiling, driven by the immense heat and pressure generated by nuclear fusion at the Sun's core. The Sun, unlike a solid planet, doesn't rotate at a uniform speed. At the Sun's equator, it takes roughly 25 Earth days for a complete rotation. However, as you move towards the Sun's poles, the rotation slows down, taking about 35 days for a full spin. The Sun isn't just a source of steady light and heat, it's also capable of unleashing incredibly powerful eruptions of energy known as solar storms. These storms manifest in two primary forms: solar flares and coronal mass ejections, or CMEs. When these CMEs reach Earth, they can interact with our planet's magnetic field, triggering geomagnetic storms that can disrupt satellites, power grids, and even create stunning auroras. Just as Earth has its atmosphere, the Sun has its own layered atmosphere, each with unique properties and temperatures. Above the photosphere lies the chromosphere, a thin layer of plasma where temperatures rise dramatically, reaching tens of thousands of degrees Celsius. And then there's the corona, the outermost layer of the Sun's atmosphere, extending millions of kilometers into space. The Sun is truly massive, containing approximately 99.8% of the total mass of our solar system. This immense mass gives the Sun an incredibly strong gravitational pull, holding all the planets, asteroids, and comets in our solar system in their orbits. Its gravity dictates the paths of every object in the solar system, from the smallest grain of dust to the largest gas giant. The Sun, like any star, has a finite lifespan. It's currently about 4.6 billion years old, roughly middle-aged in stellar terms. For the next 5 billion years or so, it will continue to shine as it does now, fusing hydrogen into helium in its core and releasing a tremendous amount of energy in the process. The Sun is more than just a source of light and heat. It's the very engine that drives life on Earth. From the earliest photosynthetic organisms to the complex ecosystems we see today, life on our planet has evolved and adapted to harness the Sun's energy. These variations may have even played a role in shaping the course of evolution, influencing the diversity and resilience of life on our planet. Deep within the Sun's core, a process of unimaginable power unfolds: nuclear fusion. Here, under immense pressure and temperatures exceeding 15 million degrees Celsius, hydrogen atoms are forced together, fusing into helium and releasing a tremendous amount of energy in the process. By studying the Sun, we gain valuable insights into the principles of nuclear fusion, a process that holds immense promise for clean, sustainable energy here on Earth. The Sun is constantly emitting a stream of charged particles known as the solar wind. This wind, composed of electrons, protons, and other particles, flows outward from the Sun at supersonic speeds, carrying with it a piece of the Sun's atmosphere far into space. By studying the solar wind, we can learn about the Sun's activity, its magnetic field, and how it interacts with the interstellar medium, the vast space between stars. We often depict the Sun as a bright yellow orb, but its true color is surprisingly different. When viewed from space, the Sun appears white, a pure white light that encompasses all the colors of the spectrum. The Earth's atmosphere is more effective at scattering shorter wavelengths of light, such as blue and violet, which is why the sky appears blue. Thank you for joining us on this journey to uncover the mysteries of the sun. The sun is more than just a celestial object. It's a fundamental force that has shaped our world, from its earliest beginnings to the evolution of life itself. Stay curious with Adisla and keep looking up. As we delve deeper into the cosmos, we uncover not only the wonders of the universe, but also our profound connection to it.